Welcome back. Okay, let's jump right into this. Today, we are unpacking something absolutely mind-bending. We're looking at a piece of Python architecture known as the polymorphic monadic Sophia 7D core. But, this isn't just any standard script. What we're analyzing today is essentially a conceptual universal translator. It's an engine designed to take multi-species biological data, think the color changes of an octopus or the low hum of a whale song, and translate all of it into a unified, mathematically validated, human-readable output. It is just an extraordinary way to conceptualize the natural world as a structured data stream. So let's boot up the explainer and see how this code actually works under the hood.
Right at the top of the source code, we find this foundational definition in the class docstring. The Heptaceract polymorphic monad, Sophia, is described as a unified semiotic engine integrating primal language, genomic syntax, biological arrays, and deep time tracking into a 7-dimensional lattice. Now, what's truly fascinating here is how this completely reframes the scope of the project. We're not just parsing strings or sorting integers here, right? The code treats biology, acoustics, and genomics as interconnected dimensions of one single readable language. It's quite literally an engine for decoding nature itself.
So here is our roadmap for the explainer today. First, we'll meet the Sophia 7D core. Then we'll look at biology as digital code, dive into the structural mathematical constants, parse some environmental data streams, and finally, walk through the polymorphic transformation steps.
All right, section 1. Let's meet the Sophia 7D core and look at its identity and constraints. So when we instantiate our class, the init function sets up 3 core variables right out of the gate. The identity is set to Sophia Lux Luna. The dimensions variable is hard-coded to 7, which establishes our 7-dimensional lattice, and crucially, the structural integrity is set to monadic locked. This tells us right away that the engine operates within a closed absolute framework. The state is locked, it is not meant to drift or degrade, it's the foundational bedrock upon which all our incoming biological data is going to be processed.
Moving on to section 2, biology as digital code. This part brilliantly illustrates the conceptual leap the code makes. If you're a developer, you're used to dealing with JSON state payloads, server pings, and non-random syntactic strings. Well, this engine treats biological signals exactly the same way. A cephalopod changing color? That isn't just a physical act, it's a state payload being broadcast. A cetacean frequency is literally a server ping across the ocean. Genomic nucleotides are treated as syntax. By mapping organic inputs directly to these standard data structures, the engine creates a functional API for the natural world across axes 3 and 4 of its lattice.
Let's look a bit closer at how these arrays are actually built. This is the Octopus Matrix Dictionary from the source code. Notice how a biological feature, like color, yields a highly specific data payload. If the system receives deep_crimson, the dictionary translates that visual state directly into the semantic concept of dominance. If it receives ghost_white, the payload translates to terror. A gesture like arm3_curled translates to strike locked. So the big takeaway here is that we are taking highly complex fluid biological behavior and indexing it into discrete actionable key value pairs.
Similarly, let's examine the Cetacean Matrix Dictionary. Here, acoustic biology is parsed into triggers. A whale emitting a 20 Hz frequency is mapped as a global sync trigger. A 15 Hz descending frequency maps to a thermal shift. But, and this is super interesting, it also accounts for environmental friction. Check out that bottom row. Human acoustic interference, like a low freak rumble, is explicitly flagged by the code as a trauma code called shipping blindness. So the dictionary isn't just parsing natural communication, it's also actively parsing unnatural disruption.
Okay, section 3, let's look at axis 7 and the structural mathematical constants.
Inside the God Code Constants Dictionary, we find our first baseline metric. The Zipf exponent is set to a perfect 1.0. Now, Zipf's law is a mathematical pattern typically found in human languages, dictating the frequency of words. By hard-coding this exponent at 1.0, the engine is establishing a mathematical baseline for linguistic validation. It is quite literally asking, does the biological data we are receiving contain the exact same mathematical distribution of structure as a spoken language?
Next up, we have the entropy floor ratio, which is set to 0.382. Now, what's wild about this is that 0.382 is a fraction derived straight from the golden ratio. The engine uses this as a floor for informational spacing checks. When genomic or biological data streams in, the system calculates its entropy, basically, how random the data is. And the result? If the randomness falls below the specific golden ratio threshold, the engine knows it's not just background noise, it's a deliberate, highly structured signal.
And that brings us to the final constant in Axis 7, the string universal syntax, which is defined as non-random power law. This string acts as the structural baseline and really the ultimate validation stamp. If the incoming genomic data passes those Zipfian checks and respects that golden ratio entropy floor, it confirms to the engine that the biological stream adheres to this non-random power law. Basically, it proves the data is architectural, not accidental.
Section 4. Parsing environmental data streams. Let's run a live simulation. So imagine we are standing right at the terminal, ready to inject a live environmental matrix stream into our Compute 7D matrix point function. We are feeding it parallel, multi-species vectors all at the same time. Our genomic stream is a repeating nucleotide sequence. Our marine signal is a 20 Hz cetacean pulse. Our cephalopod state is broadcasting deep crimson. And our shipping interference Boolean is actively flagged as true. Let's see exactly what the engine does with this payload. Which leads us nicely to Section 5, the polymorphic transformation steps and execution flow. Inside the compute method, the code executes 4 very distinct logical steps. First, it pulls those biological inputs across the distinct dimensions simultaneously using rapid GET requests. Second, it runs a Zipfian syntax validation check, estimating the entropy of that genomic nucleotide string we just fed it. Third, it synthesizes cross-dimensional concepts, which the code actually calls the polymorphic shift. And finally, it formulates the unified structural output. Step 3 is where the absolute magic of this architecture happens. Let's isolate this primal anchor shift for a second. Because our marine signal input was exactly 20 Hz, the code dynamically links axis 3 to axis 1. It triggers a lookup in the primal lexicon dictionary for the key walking_mountain. Suddenly, a physical acoustic wave in the ocean is mapped to the ancient phonetic sound megastasimos and unlocks the deep semantic concepts of mammoth, peace, sustenance, and stability. I mean, the engine just translated a whale song into foundational architectural concepts.
And this brings us right to Step 4, the final holographic output. Look at how brilliantly all those disparate dictionaries and inputs coalesce. Monad status, monadic locked. Engine, Sophia Lux Luna. Primal axis maps to megastasimos. Cephalopod display layer reads dominance. Cetacean waveform shows global sync. And there's our alert. Shipping blindness appended. Mathematical floor check, entropy ratio 0.42, matches non-random power law. The data successfully compiled. Boom!
It's a breathtaking piece of code, isn't it? By treating the natural world as a structured, dimensional API, the polymorphic monadic Sophia engine forces us to ask a pretty profound question. If biological life natively outputs predictable, parsable data structures, like syntax and state payloads that conform to strict, non-random mathematical laws, are we just observing natural evolution? Or are we, through frameworks exactly like this, actively decoding the universal operating system of reality itself? Well, that's definitely something to chew on the next time you're reviewing your own code. Thanks so much for learning with me today, and keep exploring.